In this problem, we're asked to basically determine all the features of this rational function. First, we're going to rewrite it in factored form, and then we're going to go figure out the x-intercepts, y-intercepts, holes, and all the asymptotes. And you might be looking at a different problem than this right here. Maybe yours is simpler. Maybe it's already factored. The important part is to follow the procedure that I'm going to go through, because this procedure will work for any form of rational function that you might be given in this style of problem. So the first thing I want to do is factor this. And I'm going to bring this over here and factor these pieces one at a time. When I look at 4x squared plus 23, that was weird, plus 23x plus 15, I'm going to multiply 4 and 15 together to get 60. And what factors of 60 add up to 23? Well, I think that's 20 and 3. Okay, so that makes this x plus 20 over 4 and x plus 3 over 4. Okay, now 20 over 4 simplifies, right? That's just x plus 5. But 3 over 4 does not simplify, so this becomes, in our shortcut method of factoring, 4x plus 3. And if you compare x plus 5 times 4x plus 3, this right here, to that term right there, you'll see that this is the correct factoring. Okay. Now, next part, we need to factor the denominator. And I'm just going to do that over here, and we'll erase that in a moment. 3x squared plus 16x plus 5. 3 times 5 is 15. Okay. Factors of 15, which add up to 16. That's just 1 and 15. That one's kind of easy. So we have x plus 15 over 3 and x plus 1 over 3, which simplifies out to x plus 5 and x 3x plus 1. Okay, that's the factored form. So let's write that all down here. This is x plus 5 and 3x plus 1. Now, maybe the factoring that you were doing was easier than this one. Fine, good for you. But if you have a complicated job of factoring, right, you have two non-monic polynomials, one on top, one on bottom, this is how you would go about factoring that. Okay, so once you have everything factored, you're ready to get into the real meat of the problem, which is first we're going to find the x-intercepts, and then the y-intercepts, the holes, and so on. And what I like to do, actually, is I like to start with the holes of the function, because it's easy to identify things that are equal factors. Okay, so I'm going to look at that x plus 5 and say, oh, there's a hole. It's at x equals negative 5. But remember, this wants not just the x-coordinate, it also wants the y-coordinate. Okay, so it's not going to be enough to write x equals negative 5. We need to find the y-coordinate. And here's the method you go about doing that. You take the simplified form of the equation. Okay, my simplified form is just 4x plus 3 over 3x plus 1. And you evaluate that at the location in x of the hole. So what's the location of the hole? We just talked about that. That was negative 5. This becomes 4 times negative 5 plus 3 over 3 times negative 5 plus 1. So calculate that out. 4 times negative 5 is negative 20, plus 3, negative 17. 3 times negative 5 is negative 15, plus 1 is negative 14. Okay, so the location of the hole is negative 5 in x and 17 over 14 in y. Okay, so next let's talk about the x-intercepts. And this is going to come from factors on the top, which are not also on the bottom. And this one's pretty easy to solve. You should be able to do this in your head by now. I'm just going to take that 4x plus 3 equation and solve it. Okay, so that leads me to this. Negative 3/4, comma 0. Because, of course, the y location is 0 if it's an x-intercept. And for the y-intercept, what we do here is you go back to the original equation and you just take a ratio of the constant terms, right? Or in other words, you set x equal to 0. And if x equals to 0, then those are 0, right? All that's left is 15 over negative 5, which is negative 3. Okay, so that's how you find the y-intercept. Now the vertical asymptotes. This one's not hard. This is just factors on the bottom of the equation, which are not also on the top. Okay, so that's going to be negative 1/3. And you don't write that as a coordinate because it's not a coordinate, it's a line. This is an equation, x equals negative 1/3. Okay, so that's all of that stuff. Now we're looking at the horizontal asymptote. This is the last piece. Trying to find a color I haven't used. Let's go for obnoxious green. See this right here? This ratio of coefficients is what I want because this function is x squared over x squared. It's equal weight. Okay, and remember, when you have equal weight, your horizontal asymptote comes from the ratio of the coefficients. So this is going to be 4 divided by 3. All right, and the oblique asymptote, there is none. We haven't gotten to what oblique asymptotes are yet, but they only arise in one occasion, when the power of x on top is greater than on bottom. And since this is equal weight, we have no oblique asymptote. And a quick hint, you'll never have an oblique asymptote and a horizontal asymptote. It's one or the other, okay? So if you had a simpler problem, that's fine. It should be easier factoring, but you go through each of these steps in the same way.